If you're using local files, local path, then you will not. Well, then all of the executors still need to have that files locally, and then you are responsible to push that into all those nodes. Now, if that dies, right, the whole stage has to be recalculated. So here we have a simple example, like just is basically a count. But just imagine that the thing that we were doing was basically just read from a file system, filter, map, filter, map something, right? And you know that the first task succeeded, the second one succeeded, and the third died for one of the partitions. So what you have to do is, take one more time that partition. That partition knows, everything it needs to know about, like which subset of a file it is, but you have to run the whole stage from the very beginning. It will not start from like somewhere in the middle. You just have to rerun the thing. Does that answer your question, or?
Yeah, pretty much.
Okay.
Thanks. Quick question.
Yeah.
So we talk about node failure. What about master?
Depends. Right now, master is a single point of failure that you can live with, because there are other tools that you can use that they will provide you high availability for a master. But that requires your additional configuration, additional infrastructure information. But on the default, because we are still talking right now about standalone cluster, right? By default, the master is single point of failure. So if he dies, you're screwed. But there are ways to provide high availability for a master. But this requires additional not frameworks, but programs that you use. And that's it.
Sorry. If an executor dies, and you're in, say, the second of 3 stages, implying that there's been some sort of shuffling, do you have to go all the way back to the first stage?
No. Stages are calculated, and the results are in the master. So the results are because the thing that we are showing here, the task, as you remember, the task corresponds to calculation being executed on a single stage.
Right.
So you have, if our application calculates something that is a build from 2 stages, so there are going to be first tasks running for the first stage. Those tasks will be finished. They go away. You're shuffling, and you trigger yet a new set of tasks. So what we are looking here, we are looking on a single stage.
Okay.
So those partial results are saved in the memory. So if that dies, then you have one. But yeah, as I said, master might be a single point of failure, because if that dies, you lose everything. But if executor dies, you are right. Until you provide some high availability for a master, which you can do. All right. So.
Oh, by the way, it's 3 o'clock break time.
3 o'clock. So break. We meet at what? Should we meet at
3:30.
3:30.
Yes.
What the schedule says.
So now the exercise for you guys would be pretty much, we are finally reaching the big data, right? We're gonna do the word count. Just try to write a program that will produce a word count using Spark. If you're gonna do that, you're gonna be as good as Hadoop.
Woohoo!
Yay!
There's a program called file wordcount.scala.
Oh damn! I forgot to delete that.
So don't look at that.
Don't look at that. Yes.
But
Okay.
Was there a skeleton?
You can go to exercise 5, and there's no skeleton, but we're going to continue from that, so you can just create a. So go to exercise. Great. What's going on? Yeah, go here and just start typing here. So exercise 5.
Oh, the user thing. Right.
Yeah, where the user is.
Yes, it is.
Oh.
Alright, so to make this example, this exercise a little bit easier for people who don't know Scala syntax, I'll show you how that would be implemented only in Scala but not using Apache Spark, just working on collections. So we're reading from some file from source system that gives us a iterator, we call getLines, that gives us a list. We call a map to lowercase each of the lines. We call flat map on it, so it takes a
Come on, you're giving us a whole solution.
it's a solution in Scala without Spark. We group by identity, and at the end, after result.
That's so sad.
Yeah, I already have lots of questions as to why some of that is the way it is. Why do you need a flat map there?
Because
Next 5 slides.
you already have a collection of you have already collection of lines. Sorry for this. You already have collection of lines, right? And for each of the line, you are splitting that line into words. So we will have collection of collections.
yeah,
I want to
okay,
flat
yeah.
that.
Got it, yeah. Yeah, I also don't understand what the group by identity does.
Identity is the function that returns whatever's passed to it.
So identity functions like it takes I don't know its name.
Yeah, I know that.
Anyone have-
I just don't understand what
So you have words.
What
you have
happens when you
okay,
do group by with
at
that?
this line,
Yeah.
right? You have just list of words, right?
Yeah.
And now you're grouping by what? By that word. So it's gonna
Oh,
give you like a
okay.
pair of word and a word.
Yeah, okay, all right.
And at the very end, so you will just you just have that key, that word, and a list of those words, right? And it's not the best solution that you can write. I put that crappy solution for a reason. You're gonna see in a second, but so essentially that builds you those groups, which are grouped by keys, which are your words, and the values that you have in that group is basically a list of your words. So for example, going to be a word like Juliet, and you're going to have a value for that key, but it's going to be a list of Juliet, right?
Yeah.
And at the very end, which is called size on it then. Let me finish my type. Okay. We have time till 5:30, right?
Yeah.
So you know what? There's some other cool stuff I wanted to show you guys. So maybe you just try to help make it a little bit more faster. So we're gonna continue. The reason I put that example that works from Scala collection is to show you something in parallel. So now I'm gonna with just this clicker implement a word count in Spark because that's that simple. You can just use that. So what I'll be doing is
How
I'm gonna take
much do you want for that clicker?
magic clicker. So what I'm doing is I'm taking a Spark context and I'm reading text file as an argument. I'm mapping to make the lines lowercase. I split each line into the word and I flat map those words. I group by identity to get sort of like a key and a list of those words. And at the end, I keep the slice. So when I said that Hadoop has not very intuitive programming model, and I was arguing that Spark will have a better one, I hope this proves it. Because for Scala developer, it's just the same thing, basically. Any questions? Yep.
So before you were showing how reduce by key is probably a little bit better in terms of performance. Okay, sorry, go ahead.
It is actually the next slide. I will have like in a few slides and next slide, okay?
Sorry.
Because that solution has a major flaw. And that flaw is called group by.
Well, that's
But before we're going to talk about it, I will just build some sort of foundation for it. So what we're going to do is we're going to instantiate a real cluster. So we're not going to use the local mode anymore for it.
Sweet.
I'll try to at least a little bit explain how cluster work. Talk about serialization, Spark UI, and configuration. And so let's do just that. So so some of you might downloaded Spark, extract it to your local file folder, file system, and you can follow those examples along, which I recommend. But if you don't have it, just kind of see what I'm doing. All right, so I have my Spark here. So basically, I downloaded the zip or whatever, extracted it, and here we have it. And there's a folder called sbin that has a script which is called not Spark, but start master. I just have to check it. One, is it already working? Because it might. Okay. So calling does that. We'll instantiate on this machine a master node. Remember the cluster and the master? So right now my computer is running a master node. I don't have any other computers here, and I didn't want to use Docker to make it more, crazy. The thing is, we can still treat this computer both as a master and as a worker node, right? Master will work on one of port, we will use some port, the worker will use the other, and we will have cluster on a single machine. But the idea is that it's going to be a real cluster, so it's going to be communicating through the network layer, even though it's going to be a local loop. Okay, so we instantiated a cluster, and we actually can see that, because if we go to localhost 8080, we're going to see a page which is called Spark UI. So what we see here is we have a list of applications that can be running in our system, and there's also a list of workers, which is apparently right now empty. Now, as you remember, to connect to any application, in order to connect to Spark, it needs to have this URI, which I have over here, right? It's Spark. What? Sorry.
I'm so sorry, where do we get this installation things again?
Okay, so you don't have it. So what you can do quickly, okay, I don't have right now internet connection.
Okay.
I can have it in a second.
I'll post a link to that.
Yeah, if you could post a link. So you just
brilliant.
download Spark. In order for everything to work, when you download distribution, you say like the latest version, which is 1.6.1, and select Hadoop 2.6,
Okay.
and then just download it.
Thanks so much.
What? What? Okay. Okay. So I will do it the other way around. So if it's running, then what you can get is you can everything that is running in the system is being logged. So we have logs, and there's going to be master, and out. And what I should have in that from that master is his URI. So this, why is it just doing what it's doing?
Yeah, that's right.
Okay.
Hmm.
You know what? Probably localhost will work as well. Or can anyone tell me what I'm doing wrong? Because I want to just, select everything.
Sorry, I'm not sure which URL you're looking for.
Okay, I'll just type it in. Okay, so what I want to do is I want to right now call in sbin folder start slave, and I want to provide that. So Spark, Pawel's, MVP. Okay, so I'm providing the URL to a master node, and master node runs on this machine, and it's running on port 77. All right. So when I execute that script, and I go back to the Spark UI, I'm not getting anything. Probably made some mistake here when typing that in.
Sorry, which version did you say to download?
161.
And then with pre-built for Hadoop.
Okay, it's working. So
I think you said pre-built for Hadoop 2.6.
Just give me guys a few seconds, all right?
Oh boy. Yes.
It's actually going pretty fast right now.
Oh, yeah, nice.
Well, it was.
Mine was. Oh,
Okay. So localhost works the loop. So I'm new to Mac as well, so I wasn't sure if this works as well. Present Unix. So okay, so just so to run the master, what I did was basically called sbin.master. That gives me the URI to Spark, and then I use that to fire up the slave using start slave and providing that URL. Okay. So yeah, pretty much. This is the hours. So we see that we have some worker. We know some information about it, how many cores it can use, how much memory it has, and stuff like that. And now what we can do is, actually I have the word count example here. Okay, so instead of saying connect to localhost, so to connect to local, we're gonna say connect to Spark localhost 777, right? And let's see how if this actually works. So I'm gonna go back, run it, and I have which package was 5 a word count. It's gonna explode.
oh no.
And exploded for a reason. And if we try to look for that reason, we're gonna get real weird thing. Class not found exception, some anonymous fun. What the heck? So we will come back to this example, the word count. Let's try to do something easier. So what I will do is I will create just a list of strings, list of names, and I will take 5, maybe take 4 on it. All right? And I want to run it one more time on my cluster. Let's see if that works. So it's called serialization issues. Sorry. So run. Serialization issues number 10.
No, that was the web interface.
All right, it's running.
7.
Okay, it worked. Right?
Hooray.
It worked. Hooray! So the question might be, what's the difference between this code and the word count that we have? What the heck? So I'll provide a small change here. So after we were just printing out strings, what we're gonna do is before that we're gonna create. So I have on line 24. I have a class user. So I will change the identity instead of it's gonna be not identity of strings. It's gonna be identity of users. So I will just say for each of the name, create a user with that name. Okay, that's simple change, and let's just see how that works. And it explodes. Okay, so that's single change, and make this program has run saying class not found exception user. Okay, this is more familiar than ano found something, right? So let's try to think about it for a second. Do you remember how Spark works? It creates a task for every partition. And what is task? For every partition. And what is task? Which the task is going to be serialized, right? Sent through the network to be executed on executors. So in order for it to work, the task has to be serialized. The partition can be serialized by definition, but what about our calculation? That thing that we are running, the map to something and then filter and whatever, that also needs to serialize itself, and it will. This thing will serialize this whole code, right? Serialize the task, push that calculation, that whole task to executor, and the first thing that the executor will do, it will try to deserialize it. But when it does, it reached a point when there's some kind of user in it. But the executor does not know anything about your user class. We just created that class user here on our driver program. It is on our class path. It exists on our JVM, but the JVM that is running the executor has no idea of what that user is.
If you put the user inside the object, because it serializes the entire object, I assume.
Yes. So
if you put that user inside the object.
Which object?
The case class user.
No. Because it's still serialized that user. It's we don't know what it is, but doesn't know the definition. We can do it, right? If you want.
Yeah, let's see what it does.
I'm curious too.
I like that.
Yeah.
Saved. If you get if you're running if you're running on SBT, because right now I'm running programs on SBT. If you got those class and found exceptions, it's just wise to restart the SBT because it freaks out sometimes. Anyway, that's fine. And serialized issues. Explodes. Why? Because the JVM, Java Virtual Machine, that's running on executor does not have on class path the user. Does it have and doesn't know anything about Spark? Classes from Spark? Yes, it does, because Spark, when installs itself as an executor, push to the class path all classes from Spark. It knows classes like string or integer because those exist in the JDK, in Java development kit. But I just create a class user, and that guy on my class here has absolutely no idea what that user is. So what we have to do is we have to send him our bytecode. So is anyone here who is not familiar with how Java works, like bytecode and stuff like that? All right, pretty much everyone. So awesome. So what we have to do is basically send those classes, the bytecode, with our calculations, so they can be, sent to all the nodes. So then, when the node is going to serialize that object, those calculations, they will understand what that user is. There are different ways to do it, but the one I found most, easiest one would be a plugin which you create. So what you do is you add an SBT, that plugin,
right.
SBT assembly, and now I haven't shown you guys the configuration. So this is something, if you work with Java and stuff like that, it's probably familiar with Maven. So we have the name of our project, we have the Scala version that we are using, we have the dependencies to our project to compile, right? But this provider thingy over here doesn't exist in SBT. If we didn't add that plugin, the SBT assembly, the SBT would freak out. I don't know what provider means. But the plugin gives like additional knowledge. So what we are here saying with those lines is that I need those libraries like Spark Core for my project to compile locally. But if you're gonna create the assembly, the jar, the final application, when you're gonna create that, please don't add it to the jar. However, if I add some other dependency to whatever library I need at this point, left path, because okay, you guys know the joke, right? Maybe some JavaScript developers here like, it's not funny. But if you add that dependency and not add this provider information, then okay. So what we're gonna do here, we can call something which is called assembly, and it will create a jar which not only holds our code, but it'll also pack every dependency that we have in our system, every library that we will be using, whatever. So, but we don't want to build a jar with Spark dependencies, because that's not allowed, because Spark dependencies are already on the worker. That's why we are just saying they are provided. So they are needed for us to compile the project, right? But they're not going to be pushed into the final the final jar. And this is the some additional configuration. Like for example, here I'm just adding the name of the jar. The name that we probably will most often use is just fat jar. So if I do the assembly right now, it will assemble the final jar, and we can actually see. Where am I? We can actually see that. So it's gonna be in target.
Yeah.
Scala. Yeah, pretty much here. Fat jar. All right. So that I don't want to extract that jar, but I could. So basically, it holds all our classes of our project. So even the user, right, and all the dependencies as well. So now the only thing that we have to do in order to have this thingy working is have the ability to say, listen, if you're gonna set the execution to the cluster, send that jar with it so it can be added to the class path. All right? And there's a method with weird name, add jar. And we're just providing that path, so it's target, Scala 2.10, fat, jar. All right? And now if we run it, give him a sec. He's thinking.
It is fat.
Spark is pretty fast. I don't know what happened. I didn't restart the. Sorry. So that.
It might still fail because the last error talked about serialization, failing to serialize that. Yeah.
Yeah. So you want to assembly that, and let's try to run it. Run. And yay, we have the final results. Now, there's one tricky part. Just you guys to be aware of. I have a simple just to be. This is related to Scala 2.11. I can show you the bytecode, or you can just believe me. What do you want to have? The belief or the knowledge? You trust me. Okay. So till Scala 2.11, it's going to change in Scala 2.12. Lambdas are basically anonymous instances. Instances of a class that is generated for you. So that lambda here, this one on line, pretty much that one. How it's going to be represented in the bytecode? It's gonna, when we compile that code, it's gonna, or maybe I will just show you that one thing, and rest you have to believe. So if we go to target, and we have Scala, so ls Scala classes exercise 5. Check this out. We have that simple class, right? But beside that, there's also some simple anofan class, whatever that is. This is actually a new class created that will represent that single lambda. This is how Scala tries to be functional in the Java world. There have been changes in JDK 7 which allows to make it more efficient, and that's what they did. And it's going to be available in Scala 2.12. But till now, this is yet another class, like our user. So whenever you're using Lambda in your code, don't be surprised to get that class not found exception. You have to add jar in order to get it to work. That's why we had that problem with in the beginning with a word count, because when we were doing word count, we actually were just using strings and stuff, and it still said, oh, I cannot create a class not found exception, on or something. That was exactly that. That was those that lambda over here, that lambda here, and that lambda here, because those were pretty much a new class. And if we do the add jar in the word count example, actually, why not? Target Scala 2.10, but jar. If we do just that and run it,